Hello! In this video, I would like to briefly summarise where we have got to and where we are going next. So in previous weeks, we have studied the sample mean at length. This random variable is computed using the expression shown on this slide. In this expression, each of the xi in the sum must be an identical random variable. All these random variables thus have the same value for the expectation mu. In addition, we have also assumed that all these random variables are independent. All the random variables thus have the same value for their variance, sigma squared. We have seen that the expectation for the sample mean x bar is equal to mu, because all the random variables are independent. In other words, the expectation for the sample mean is equal to the expectation for the underlying random variables. In addition, we know that the variance of x bar is equal to sigma squared divided by n because all the random variables are independent. In other words, the variance for the sample mean is equal to the variance for the underlying random variables divided by the number of random variables that were added together to generate the sample mean, as long as all of the underlying random variables are independent. The key point I want to start out by acknowledging this week is that although we know the expectation and variance for the sample mean, we do not know what distribution is being sampled yet. The objective for this week is to investigate the probability density function that is being sampled by x bar. Hopefully, given all that we have studied in previous weeks about estimating histograms, you already have some inkling as to how we might go about performing such an investigation. After all, you have seen from the Python exercises how we can write a function to compute a sample mean by adding together n random variables in a code like the one shown here. In addition, once we have a function to generate a particular random variable, you have learned how we can call that function repeatedly and estimate the probability density function for the random variable that is being sampled using code that is similar to the Python shown here. This code simply divides up the range of possible values that the random variable can take into a discrete number of bins. You then generate a series of random variables and count how often each of those random variables falls into one of the various bins. Your task in the first of these exercises is thus to write a code like this one and to thus estimate the probability density function for the sample mean. Once you have done this, we will then investigate what can be done with this particular probability density function. I hope that is reasonably clear. Thanks for your attention and good luck.